Alright, so in this video we're going to be reviewing a job recommender system, which is a document-based recommender system to recommend tailored jobs to users. Now it's going to be an end-to-end system. We're going to be getting the jobs, doing all the gymnastics and deploying with Docker. Let's go. Alright, welcome to Data Code. We'll talk about AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision. Deep learning, AI, NLP, AI. Alright, so here you can see the overall architecture of the system. Each shaded area is representing a separate Docker container. We have one container for the Cassandra database. We have another for the backend and all the other things that are going on with the vectorization and the server with FastAPI. Then we have the vector database where we're using Chroma DB here. And then for the front end, which is where the user is going to interact with the system, we're using Streamlit. All right, so I'm just going to jump right in for the back end here. Let me just close this and this. For the back end here, let me just quickly show you the requirements. All right, so we're basically going to be using Selenium for web scraping. We're going to be using Beautiful Soup to parse through the HTML files we collect, Cassandra driver, and just a whole lot of other things. You can check it out in the repo. In this video, I'm just going to be doing a surface run through of the separate components because it's quite a bit of a lot going on. So for this video, it's going to be a basic run through of the entire system and then a quick demo. Quickly, let's move on to the scrapers. All right, so that's going to be in the ETL extract. Let's close databases first. Okay, extract. So site scraper, the pie. All right, so for this project, we're scraping a number of websites. We're scraping Indeed, LinkedIn, and Jobberman. Don't worry, there's no illegality here. We're basically going to be redirecting the users back to the source of the job, so we're not taking ownership of the jobs. So I believe it's completely legal. We have a basic abstract class here, which tells us all the methods that are going to be available in each of the scrapers, because we're basically just going to be inheriting these properties across all the scrapers for consistency. So we'll have where the scraper itself and Selenium and all those things will be initialized. And we have the scrape method, and then we have the get jobs method, which is going to extract the job cards, and then get job details, which is going to get the full details of the job based on the information on job cards. And then we have create data frame to create a data frame from all the jobs before we then push to update the database. Then we have a generate UUID here. Now what this is basically helping us to do is to ensure that all the jobs that we scrape are unique, and it ensures that when we're scraping, we can filter for jobs that we've seen before, so we don't have duplicate jobs on the database. So using this, we now have the Indeed scraper, and a lot is a bunch of code. That's why I say I'm going to have to explain these in separate videos. All right. Next thing we have is the database where we're keeping this data, right? And of course, the other data like user data and the metadata and stuff. So for Cassandra, this is just a basic class to connect to Cassandra, because we're going to be using it over and over across the script in a lot of places. All right, so we'll just connect, get the session, and all those other plenty gymnastics going on. Right now, something here which we've done just to make the entire flow of data consistent is to use Pydantic. Pydantic is awesome. So Pydantic helps us to create data models so that it automatically validates data as it's moving across the system. So we have data models for the user, jobs, search metadata, and clicks metadata. And we have a separate script here just to set up the database when we're firing up the server and all that, right? Then another thing we have here, which is beautiful, kind of like how SQL Alchemy works. Cassandra also has its own system for creating table models now for the schemas and all that using the base model class. So we can now have a table for users, job listings, and all the other stuff. And the cool thing with this is that we can explicitly define the connection, the key space, the table name, everything within that schema. So we can just call it as a unique object elsewhere in the project. So I'll show you that as we go. All right, so similar stuff is happening with Chroma, the connection, data model. Now for Chroma, it already has a predefined schema. The developers have already done that because it's basically just going to be used to store vector data, right? So there's no point making it too flexible. Although initially I started with Milvus, which gave that flexibility to define, but the container just had issues, it kept shutting down, so I just switched to Chroma. Yep. All right, so setup will be similar to what we're doing with Cassandra, where we just want to spin it up during server deployment. In order to interact with the database, we now have the routes for each of these tables that is going to link to the main server script, right? So we want to check out all the users on the database. Instead of writing like an entire query, select star from this, that, because we've already defined the user data model and the user table model and everything, it just becomes one line. Like we want to get users to just say users to objects to all. Is that not beautiful? And it's also more secure here because, of course, all the standards of ensuring that you can do stuff like injection and all has already been implemented as part of the interface. So you just have to call the specific methods that have been defined on how to interact with the database with this. Of course, um, elsewhere for some things that are just way simpler than this, I just defined queries as you see moving forward. But for these specific cases, it makes things very easy. All right. So you see now, when the response model can easily be defined as list user because we already have a class that represents each user and all that. So it just makes the code cleaner. All right. So that's that. For Chroma, I kind of tried to do the same thing, although it's just like a makeshift route job index. Okay, so here a little bit more is going on. I'm just going to explain the whole recommendation logic before coming to this. Just a basic run through of the recommendation logic before coming to this job index API route because it's not going to be intuitive to explain it like this. For that, the first thing we want to do is because it's a document-based recommender system, we're basically comparing one document to the other, right? So we want to create, we're going to be vectorizing all those jobs from the Cassandra database. So we've collected all the job details. We vectorize and push it to the Chroma collection. So in order to search the Chroma collection, we're going to have to create a sort of document, vectorize it, and then use that to compare against the jobs so that we can get the most relevant hits to that other document, which is the user profile. So for this, now I want to get the user's previous searches. Okay, so you can see here I wrote queries. Haha, yeah, just because it's easier. All right, all right. So we're going to use that to get the previous searches. Now we'll get the previous click interactions of the user so that from those clicks we can now load the data descriptions of the specific jobs that the user has clicked before, and then we want to get the user's basic information like their skills, work history, and just specific preferences that we've defined that users can give on the platform. All right, so all this is then collected here using this helper function called get user metadata. It collects everything and forms a document from it, which you can now use to search the vector database. So you might be wondering, oh, how is this embedding that I've been talking about happening, right? So here we have it in the models, embedding model. Newsflash, I did not train a custom embedding model. I'm using all MP NetBase v2 version 2 from Hugging Face, the sentence transformer Hugging Face thing going on here. Now, of course, you could train yours, and an alternative to this would be a collaborative filtering model for recommendation where you actually compare different users' behaviors to say, okay, if this user's behavior is similar to this other user's behavior, then let's recommend the content that this user has interacted with to this user, right? But here's the big question: where are the users? You will become the user, so we'll use your information to build the next model. Haha. Now you understand what does the vectorization, and you understand what we are vectorizing to bring the recommendation. So beautiful, beautiful, beautiful. Now let's move on to the server. Uninteresting. Why is it uninteresting? Why is it just 20 lines? Because I've already defined the routes elsewhere, so not a lot is going on here. We're just importing all those routes and adding them to the main server. Beautiful, simple. So the next thing you're going to ask is, how does the scraping work in deployment? So I have a pipeline for that. I'm just hoping I can find it. Okay, so here it is. We'll just call the scraper with retry because things can happen and we need to retry. Indeed scraper, Jobberman scraper, LinkedIn scraper, scrape all the jobs, update the embeddings in the Chroma collection, and scrub the older jobs, because as we're adding new jobs, we don't want old jobs building up. Anything older than 30 days from the date it was scraped gets deleted, just to make the platform fresh for you. So the next thing is the cron job. Here's the cron job. So what the cron job is basically like a scheduled activity that's supposed to be repetitive. So what this cron job is specified to do is to run every day, every month, every year by 2 a.m. OO. And it will run the scraping pipeline to get the jobs, clean the old jobs and everything. What we expect is for the jobs database to increase over time as the platform is being used in real time. Now that that's been done, we're just going to move on to the front end. Here's the front end. Not a lot of things going on here. Now I've used a Streamlit app for this. Now, okay, yeah, so I'm just going to open the requirements so you can see it here. Streamlit extras because I'm extra. PyYAML just to open the configuration YAML files. PyTest because we need to write tests. Yeah, we need to write tests. Yes, we need to write tests. And then we're going to move on from the requirements file, utilities, config.py. So here, this is just a class that helps us to load the configuration files based on whether we're running in deployment or local configuration. The logger, because we have logging going on everywhere. Now, this is very important. Hasher.py. What is hasher.py doing? Hasher.py is ensuring that I don't know your password and you don't know my password. So once you enter your password, your actual password is not what's being stored. It's the scrambled and humanly not understandable version that is stored on the database. And each time you want to log in, we will scramble your password based on the same algorithm, and then we compare it to what we have on the database to ensure that it's you and not your cousin trying to search for jobs with your user. I don't know why your cousin will want to do that, but just in case. So the next thing we have here is page styling, because Streamlit basically has preset formats for everything, but I just want to add some pizzazz, you know. So yeah, this is just to add a background image to the page itself, to the form, and then to open links, because we're going to be linking you back to the actual website where we've got the jobs. We're not going to be claiming ownership to the jobs, right? Yes. And then some other stuff here, so I don't have to retype stuff in Markdown, then refresh, because we're going to be refreshing stuff every time you click something, right? I don't want to have to write these 3 lines every time. We have the home page, a whole lot of drama going on, which I will not get into now because this is not dedicated to front end alone. We're just doing a run through. All right. And then we have the other pages, search jobs, and your profile. Here is the Docker Compose file. Backend, front end, Cassandra. I got this from the internet. I just added a few things here. I added this test just so the other containers will wait for the database to be set before spinning up, because they need the database. So that's how this works. To spin up the containers, we're just going to use this command here, like this, a la this, right? You just do this and enter, but I don't want to do that because I've already done it, and if I respin it, I'm going to have to re-scrape jobs, and I don't want to re-scrape jobs because of a video. Now we're just going to go into a quick demo. So let me pull up Docker. So here are the 4 containers that I told you about. We have one for the front end, the back end, Chroma DB, and Cassandra. So if I want to open the front end, I just come here, click this, and hopefully it works. Yes, it works. Okay, this is the one I was playing with before. Now you could log in as an admin, or you could log in as Adam Smith, who's my favorite guy. If you're coming here for the first time, you could create an account, but you cannot use DigBig 2023 because it's reserved. Don't ask me why it's reserved. It is reserved, right? But I don't want to create an account, so I'll just cancel that. I want to log in as an admin, right? Admin. So when you log in as admin, you can set up database, but it's already set up, so it will tell me it's already set up. And I can trigger the scraping of jobs, but I don't want to do that because that's computationally intensive, and my system is already crying because I'm recording, I'm using Docker, and I'm doing a lot of things now already. I can get statistics. So we have 13 fake users because I created 13 fake people to test it by the 13 different temperaments. No, there are not 13 different temperaments. And then 933 jobs, doing great already. All right, so I can just exit admin and log in as Adam Smith because we love Adam Smith, right? Log in. So because his profile is complete here, not going to tell you to do anything. So yeah, I think I'll just log in with a different guy. New user. Login successful. All right, so you can see the new user doesn't have a complete profile, so it tells him, yo, update your skills, your work history, and your preferences so you could get, because we're trying to help you, bro. Yes. All right, so if I click on update profile, it just jumps straight to profile, and then I could do like a whole lot of updates, and of course I can delete my account. Now here's for the cool part, which is the actual recommendation stuff. Hope it doesn't break. All right, so when you click on search without putting any queries, we will understand that you are a lazy son of a and you don't have the time to search for things. We don't know who this guy is, so we're just going to recommend random stuff. Yeah, you're going to see just the top 3 jobs. Now we have 2 for LinkedIn because initially when I was testing, I didn't know that LinkedIn had this funky way of getting past my UID thing, but I fixed it later. But I didn't want to delete all the jobs and start all over, so that's why we have 2 of the same jobs from LinkedIn, but it's fixed now. Trust me, bro. Trust me, bro. Now I can search Python developer and search, and boom, you can see that results are coming in 0.08 seconds. I'm good. And now by searching Python developer, because we probably don't have a Python developer job script yet, the best thing next to Python developer is data analyst, because data analysts only know how to use Excel and Python. That's it. It works, guys. It works. Thank you for watching this video about job recommenders from end to end. I mean, from scraping the jobs up to serving it to the end user where they can search using a document-based recommender system. This has been Data Code Pie. Like, share, subscribe, share it with your friends, your frenemies, your enemies, and the other me's of the internet so that they can learn about job recommender systems, how they work, and how LinkedIn kind of sort of recommends. Mine is like the broke dude version.